And we're back with some Captain of Industry, and today I thought we'd try something just a little different. You see, we need to build something, and it's going to be something that's, well, mildly complicated, and that's our oil upgrade. We need to upgrade all this oil to distillation level 1 and 2 and all sorts of stuff, and I feel like I cut out most of this stuff in the background, and it's what I consider the most fun part of the game. So let's hold on a second while we jump to a little test map where we can demonstrate some of this fun. This here is a test map I made earlier. It'll look a little bit similar to our active island, except for the fact that there's an awful lot more trees around because, well, we've just been testing stuff out. As well as that, we have installed Captain of Cheats. It's a mod that allows us to just, well, build stuff instantly, turn on and off a bunch of things, and just generally engineer things so that we don't have to work too hard to test out particular builds. And the reason we're doing this, well, actually, you do this in a lot of games. Oxygen not included, RimWorld, all this stuff. It's always good to have access to, well, debug menu, developer mode, cheat engine, whatever it is that allows you to test things quickly and efficiently. So you don't have to spend hours in-game testing something only to realize it doesn't actually work what you were trying to do. At least figure out what you're trying to do. That way, when you build it in-game, you know it'll work. Anyway, okay. This here is how we are currently refining oil. We're taking 54 crude oil, 6 coal, we spits out 24 diesel, some wastewater and an exhaust or whatever. Wastewater we dump into the ocean, the exhaust we dump into the sky, and that means we're getting 24 diesel for 54 crude oil. That's the really big numbers there, or the 54 crude oil gives us 24 diesel. However, there have been some new technologies opened up for us in our playthrough, and it is these ones. This here is distillation stage 1. It takes in 54 crude oil and gives us 48 medium oil. Ignore the other stuff for a minute. Of course, medium oil is not diesel, but we can take that 48 medium oil and we can turn that into 36 diesel. So we're effectively taking 54 crude oil, turning it into 36 diesel, which is a big improvement on the 54 to 24 we're getting over here. 50%, in fact. And there's bonuses and negatives and all sorts of stuff going on here. Downsides are, well, upsides of this one is, it is super simple. You just plug it in, you're good to go. Upsides of this is, saves you an awful lot on crude oil. Makes things much more efficient. However, you're going to end up with a bunch of waste products. Also, you need steam to make this work. So we need high-pressure steam to make this work. We also need high-pressure steam to make this work. So we have to get that high-pressure steam from somewhere. As well as that, we're going to have heavy oil, which we will need to dispose of, and sour water we need to dispose of. And we're also going to have light oil. All of these things need to be disposed of. Sour water you can toss into the ocean. The heavy oil and the light oil are trickier. So let's try going through all of these and figuring them out. First things first, that high-pressure steam. Where are we going to get that from? Well, that's not actually too bad. We have access to the boiler. Boiler takes in coal and water, produces high-pressure steam. Not going to use this. This might be used to jumpstart the system, but what we have over here is the gas boiler. This thing can take in heavy oil and produce high-pressure steam. So the heavy oil is the waste product from here, so we can use that waste product to provide the high-pressure steam we need to run the system. Also, as well as that, this light oil that we produce as a waste product over here, that light oil can also be turned into high-pressure steam. That's a lot of steam, and we're probably not going to be able to use that all, feeding it back into the system, which means we'll have an excess of heavy and light oil that we're going to need to dispose of. But we'll get back to that. However, that does remove the need for high-pressure steam production. We can do that using the gas boiler and the waste products from both of these. And this is not too much of a negative. The main negative we're looking at here is it's going to take a lot more workers to make all of this work and a lot more maintenance on all of these buildings, because they're all going to require maintenance. So we're going to need a lot more people, and we're going to need a lot more maintenance to keep everything running, and we get 50% more output from our oil. Oh, so far. All right, next up. The distillation stage 1 does produce this sour water, and what we can do is build a sour water stripper. We don't have access to it in our current playthrough just yet, but we will gain access to it. Better to plan ahead if we're going around and doing this design right now. So sour water can be with high-pressure steam, which we can produce using some waste products. Will give us sulfur and ammonia. And then you're like, wait, what? Where did those come from? So, like, these are all of the buildings we're looking at so far. Okay, we can get rid of that coal boiler. But we're going to need all of these systems just to do what this thing was doing beforehand and disposing of some of the waste, not all of it. We're still going to be left with sulfur and ammonia. However, they also have uses. You see, sulfur can be combined with diesel to make rubber. So this means we can have a rubber maker producing, well, rubber without the need for coal. So this rips coal out of a production chain and instead puts that coal, or puts that this rips coal out of a production chain and replaces it with sulfur to make the rubber, and it all comes from the oil, so it means we're getting rubber from oil, effectively. Assuming we can produce enough with the amount of sulfur we're getting out of it, which is one of the things we're here to discover. There's all of these balancing acts we're going to have to do. That still leaves us, though, with the ammonia. That also has a use, though. You see, we can build this chemical plant, and we can take that ammonia, which is the final waste product. Yeah, we got rid of the sulfur. It's just the ammonia left. That ammonia, we can combine it with oxygen to make fertilizer for our farms. And the great thing about fertilizer is it improves the yield. So currently our yield is 78.62% or something like that, because we're using a little bit of well, there's some stuff going on there we don't want to get too deep into. But basically, we can improve the efficiency of this by fertilizing it. If we fertilize the soil, its fertility should max out about 100%, maybe more. Well, that would mean we would be effectively getting about a 50% or 45 to 50% increase in productivity out of our farms. Which means we wouldn't need as many farms, which means we wouldn't need as many people working the farms, which saves population from over here, assuming we make the fertilizer by combining ammonia and oxygen to make that fertilizer. However, there's a problem. Well, we don't have oxygen, right? So where do we get the oxygen from? I mean, yeah, you're seeing how this is working out right so far. Well, we build an air separator. Okay, and then the air separator will give us oxygen and nitrogen. We just feed power in there and we get oxygen and nitrogen out. Perfect. That gives us the oxygen to combine with the ammonia to make the fertilizer. Great, but that leaves us with nitrogen. And what do we do with that nitrogen? Well, I'm dumping it. I'm just... the chain's gone too long, okay? From what I can see, there's these menu things you can look up here, and under nitrogen, you can either dump it out of a smokestack, or you can combine it with hydrogen to make more ammonia. To make more hydrogen would require electrolysis. Electrolysis is further along on the tech tree. You see, right now we're kind of limited in what we can do by the tech we have access to us in our playthrough. So I've done the same thing here. I've only researched up as far as this point, which is Tech Lab Level 3, which we will be able to obtain with our current technology level. However, that leaves out a few things like, say, electrolysis or stuff like that that's all further down the tech tree. So we have to come up with an oil build that works with just these buildings here, is balanced, will work out, shouldn't have any backups, and do all of that stuff, while simultaneously only using the tech below this point here on the tech tree. What we want to do is make sure we have enough of this to then, well, be able to use to tech all the way up to the next research lab level 4. So once we've built this oil well, it should support us all the way up until we've knocked out all of this tech. Oh, and one other thing about the oxygen production out of this. We're going to need this oxygen for two things. There is an oxygen furnace. This thingy down here, it's for making steel. So you put in molten iron, combine it with oxygen, and you get molten steel out. So yeah, we need to actually get oxygen for that as well. So I don't think that's going to be part of this chain, but on the bright side, we will have fertilizer at the end of this. In fact, we could, in theory, make fertilizer level 2 by making a mixer. A mixer just requires limestone, sulfur, and fertilizer level 1, and you get fertilizer level 2. I have no idea right now what the difference between those two is, but I'm assuming since it's a 2, it's better than a 1. That would be the theory. So we could make fertilizer level 2 as well. So somehow I have to figure out how to combine all of this together. At the end of it, we're still only going to get 50% more oil, but... oh, and there's one other bonus we've got on top of that we also have to fit into this whole mess. Oh, God, okay. So this thing here is going to be taking in the waste products of the heavy oil and the light oil and turning it into high-pressure steam. One other thing we can do with all that high-pressure steam is power production. We can feed it into a high-pressure turbine. This high-pressure turbine produces 6 megawatts of mechanical power, which we can then hook up to power generators. Those power generators can generate, what? Turn 3 megawatts of mechanical power into 2 megawatts of electricity. Ooh. Oh, and we can put on flywheels to somehow store the energy. I'm not sure exactly how those work, and we can keep daisy-chaining this stuff along in a straight line. Though don't try and get any trucks across that. I think it would be tricksy. Anyway, we got to take all of these buildings and combine them together into some sort of functional thing, and that's sort of the joy of the game. And I think I kind of miss out on that, or explaining that when I'm doing this game, is you tend to just sort of look around and go like, yeah, we're going to hook up this to this and this to this and this to this. But in the background, you spent like several hours trying to figure out, how am I going to make this work? This is just insane. I love this game. It's like, it's just got that stupid level of, yeah, you're going to have to daisy chain 10 things together just to make the same thing you were making before, but it'll do it more efficiently and give you some other byproducts that you can then use to do other stuff that you couldn't have done before. But consider the amount of people and maintenance involved in this. You're going to then need to build up all of your maintenance production, because you're going to need to be able to produce enough maintenance points to support this many more machines. You're also going to need to increase your worker count to have workers to work all of these machines. And at the same time, we will get fertilizer, which will decrease the amount of workers needed on our farms. Well, decrease the amount of farms we need, while compressing it down and making sure they take up less space. But a lot of that extra spaces and workers are all going to be taken up by this. I'm not even sure if this is going to be more efficient worker-wise, if we're better off just brute forcing it with lots of basic distilleries. but I want to try. I mean, it's the whole point of the game. Now, let me start doing some playing around here and seeing how we can figure this out. This is a very basic start. Like, we're going to rough this out and then try and compress it down later. For now, we're going to give ourselves some room so we can figure out how we're going to spaghetti all these pipes together. This here is going to be our steam production. So we're going to leave, say, heavy oil in one, and then the other will make specifically for the light oil, so that we have one doing each. I don't want both of them using the same stuff. Then we'll have the oil from these somehow routed around into there, and then we're going to have to make overflows and stuff on it. But for now, this should be just the basic starts. Let's see what else we can chuck on here. So this abomination is the basics. 2 gas boilers at the rear, and then 1 coal-fired boiler just to kickstart the whole system. Once that kicks in, it'll start dumping oil and steam in here. That'll give us medium oil, heavy oil, sour water. It should all get processed and dumped into these containers. From there, we can start doing other stuff. But let's fire this up first and see if it works. Well, we're going to have to find a source of oil, but that shouldn't be too difficult. Right. The oil was a little bit trickier than I thought. I actually had to pump it over from an oil source way over there. Though, if I had been thinking, was there a closer oil source? Actually, no, there's only 2 oil sources on this island. There's one over here and one way over there. So I'm thinking in our playthrough, the oil is going to end up in this section of the base. Anyway, where were we? Get rid of that. This seems to have at least started. This is processing the oil, and so is that one, but they're running off this. This is what's actually produced the steam so far. These guys don't appear to have received their light oil yet. It's going to take a while for it to filter through the system. That is sour water, that is heavy oil, which is doing nothing, and that is diesel, and that is light oil, which is not being processed. What is going on here? And let's let this run a little bit longer. Maybe it takes a little bit of time for it to all push through the system. We're starting to see heavy oil show up there. We're starting to see light oil show up there. Yeah, perfect. Now comes the next stage. We've got basic diesel production down. We've got a little bit of light oil and heavy oil. Actually, the heavy oil and the light oil seem to be completely consumed by the gas boilers. I'm not sure if the gas boilers will just keep consuming stuff no matter what, because as far as I'm aware, looking at the numbers, we should be producing far more steam than we should be consuming. So there should be a backup happening here, but I don't see it yet. Maybe I just need to keep running it longer. Anyway, the sour water. This stuff's giving off wastewater, which you can dump, but we want to process that. So the stripper here is turning it into sulfur and ammonia. The sulfur, I've tried to do a little bit of, I wouldn't say it's load balancing, but just a case of sulfur has multiple uses. If we check under here, you can see sulfur can be used for making rubber. It can also be used for making acid. It can also be used in the production of fertilizer level 2. Let's make slag out of it, though. I'm not sure I'd want to. Maybe. There's options for it. However, what we want to do is have one branch of this go straight in here. So we've set up a little priority splitter. This is a U balancer. There's balancers for all the different types of things. So you get balancers for your transport belts, balancers for your pipes. All of them do effectively the same thing. It's just they're for the different types of transport. And what we've done here is this is set to priority out, as in the one on this side, it rotates with you. That's pretty cool. So this one here is set to priority out, meaning all of our sulfur will get stored here. That sulfur will get fed into rubber production. And only once this is backed up, let's say, what happens if we put that down to there? Will that be classified as blacked up? Huh. What you doing? No, it will still accept it above the market, or above the value. Fine. Yeah, this will go up to 180 sulfur. Once this is stockpiled up, all the excess will get dumped in here and will allow people to pull from it. This one here, no one's allowed to put anything into it, or to take anything out of it, or into it. So no one's allowed to put anything in or out. All the sulfur is going to come from this section here. That just makes sure all sulfur will be prioritized towards making rubber, which is absolutely essential. You see, one of the big killers in this game is maintenance. Now, where did I put the maintenance building? Over here. Maintenance is what keeps everything running, and if your maintenance bottoms out, you're in a lot of trouble. So you need to feed it constantly with mechanical parts, which are made from iron, and electronics, which are made for copper and rubber. In fact, if you search under rubber, its only purpose, the only things that consume it are electronics. That's it. It has zero other purposes in this game by making electronics. Electronics have multiple purposes, but one of those main ones is maintenance. So we need to make sure that we keep rubber production going, which is why I've set up this little splitter system here. Just to make sure we always have a backlog. The excess sulfur we can find a use for later, or I'm sure we can find some ways of dumping it. Anyway, that leaves us with ammonia. Right, fertilizer time. This oversized abomination is what we're left with. I mean, okay, remember, prototyping. You're just trying to figure out where everything goes. This here is where the nitrogen comes out. We have a little splitter up here, priority ones that we've always got a nitrogen backup for our fertilizer production. Or, yeah, ammonia. Sorry, that's ammonia, not nitrogen. I'm getting confused. And then we've got our oxygen over here coming from this air separator. So the oxygen and the ammonia get chucked in here and gives us fertilizer. The fertilizer is then piped all the way over to fertilizer. Now, I remember reading somewhere that fertilizer can't be carried by truck. It has to be put through pipes. That could complicate things a little bit. Stored fertilizer, 40%. What's this? Fertility target? No, not. Make that 100% if you wouldn't mind. Oh. Is that... The fertilizer is kicking in. That's kind of nice. Yeah, let's take us all the way up to 100% there, why don't you? That makes the farms much more efficient. Not enough that it's going to counteract all of the extra maintenance and people we're going to need to run this. We're still going to need to probably put out an extra farm, even with all that fertilizer, just to feed all the extra workers we're going to need to run this monstrosity. But it does cut back on the oil consumption. That's sort of where it comes down to. If we check over here, you can see down here it tells you how much crude oil is in the ground. There is 93% of the oil left. We have consumed 3,500 of it, roughly. So that stuff is going to go away. We need to find an alternative source of that, which was probably going to involve this port thing over here, the cargo depot, importing the stuff from oil rigs and derricks and stuff like that. So this stuff is just to get you started. It's your bootstrapper. So we're going to need to set this up, preferably somewhere close to the farms for piping this in, close to a water supply, so that we can actually provide water to the oil rig system, while at the same time, actually, water shouldn't be that bad. We should only be sipping water after a while, considering the recycling that will be going on. Oh, and that's one other thing. This the stripper here produces water, so that water is then, I think, output through here, and we have a priority splitter here to make sure that that water gets priority to get fed back into the tank, to get fed back into the boilers. In fact, let's turn this off and see how much water that starts slowly draining out of the system. And that's it. Now, there is one downside, this nitrogen here. We're producing oxygen and nitrogen, and the oxygen is used for the fertilizer. The nitrogen, we do not have a way of disposing of it just yet. If we do a search under nitrogen, the only things that consume it are chemical plant combined with hydrogen. Hydrogen, unfortunately, we can't do anything with. We have no active ways of producing it at our current tech level. So until we get the next level of tech up, that nitrogen is simply going to be burned off. For that, we have put this down here. Pipe balancer, one of them goes into a tank, the rest of it just gets sent out a pipe segment, which then dumps it out a smokestack. Yep, that's, we're just polluting the world with nitrogen. I don't know how much of a problem that is, to be honest. Nitrogen is 70% of the atmosphere anyway, so shouldn't be a negative. Suppose we'll find out. Anyway, that means we get rubber, we get rubber basically for free doing this method. We get fertilizer effectively for free as well. Actually, no, we take people in maintenance to make it. We just got to figure out how to take this stupidity and compress it down into something that's not quite so ugly. It takes up an awful lot less space. And, oh, and this sour gas stripper over here consumes 36 sour water. 2 distillations level 1 produce 36 sour water. So this will perfectly eat all the sour water produced. I was going to actually put down an extra sour water stripper, but if we go under sour water here, you'll notice only a few things can produce it, and we don't have access to any of them. Basically, cracking units later on, which we'll get access to in chemical plants. So we can make this thing, and then we're going to have to redesign this whole thing again later, which is sort of half the fun. Also kind of annoying. But let's see about making this a little bit more compact. This here is the start of compactifying it down a bit, making it a little bit closer together and less strenuous. We'd probably push those a little bit closer, but we'll worry about that in a minute. We've got your crude oil here, your water input here, it turns into steam there, and then that steam pipe. Well, basically I discovered that steam was the most common input. There's 7 either inputs or outputs of steam somewhere. So 1, 2, 3, 4, and 5. All 5 of those require steam, and these 2 actually output steam. So we were running this pipe, that's the one we prioritized, and once we'd hooked up all of these to steam, well, we would need their outputs. And this is, well, standardization. Me, personally, I like to standardize things even if it's a little less efficient so that my brain can just parse it and just handle it better, because otherwise you get too lost. You can worry about compactifying it down later. Or, of course, we could go look up tutorials by people, but that's no fun. It's our first run. We want to, make our own mistakes and see how it works before we start, stealing from other people and start combining that stuff together. So what we've got here is a pipe balancer with a priority output for these tanks. That means any of the heavy oil that gets produced here will get put into this tank first and then get sent over to get turned into steam to keep this whole system running. Any light oil, same thing. The light oil that goes in here will get sent over here to get burned in these things. So, oh, damn it, I've probably got them reversed. Whatever. One of them's light oil, one of them's heavy oil. They'll get sent over there and they'll get burnt off. If, however, these start to back up, we can run a line off these and have them to be a lower priority and use them to generate power or burn it off in some other way. It just gives us the option to run this out of here to use for other stuff. And then over here, we're going to have our sour water. Sour water is going to get fed into the sour stripper. The sour stripper will turn that into sulfur and ammonia and all that stuff. Oh, we haven't actually finished this one yet, but the distillation stage 2 here is going to produce diesel, and that diesel is going to get dumped over there. And we've also got a little overflow system just in case. We're basically leaving these splitters here, or these pipe balancers, so that if we need to overflow any of these, we can. A little bit of preemptively anticipating that something's going to go horrifically wrong and we're going to have to drain off the excess. Worst case scenario, we can just chuck on another liquid tank or something like that to store the stuff. All right, but fertilizer, we got to build in rubber. Rubber and fertilizer need to be built in off this stripper over here. So give us a second. Second completed, and we have this rather neat looking rubber maker chucked in here. Okay, neat is maybe a little bit of an excessive description. So what happens here is the sulfur comes out of this, and it comes all the way around to this front splitter, just to keep things correct. Like, there's splitters at the front, and then it prioritizes out the back to actually go all the way back around here to feed into the rubber maker. So yes, we're bringing it all the way to the front of the splitter to bring it all the way around to the back, for no other reason than so we can just prioritize the flow. And that means this thing here up the front will be the overflow where all our sulfur will go, and we'll find some use for it. We're going to end up with too much sulfur at some point, and we'll have to do something with it. So that leaves it all up front. And we're leaving all of our outputs up front so that we can pull them away as needs be. So that leaves rubber done. That leaves sour stripper done. We just need to do fertilizer then. Once fertilizer's done, we'll put a liquid tank up front for it. I think that will be... yeah, I think that will be our little oil design completed. You know, this thing worked out okay, except for this huge gaping mistake I made where I forgot to put in the unit storage for rubber. It should have been here somewhere to make this all nice and neat, but it's fine. I'm not going to redesign the whole thing. We're going to have to rip it down again at some point anyway. This just looks like a nice, neat design, and we won't... we should be preemptively designing for stage 3 research and stage 4, but you know what? That's no fun. It's nice to just come up with the new designs and then keep ripping them out and replacing them. That's just sort of the joy. You see what the designers intended. Anyway, up front, we're going to have the rubber pop out there. We're going to have the diesel pop out there. Sour water should immediately get sent to the sour stripper. Light and heavy oils will all get sent over here to run the boilers. That's water over there. But we're going to have water come in here, and then we're going to have that groundwater pump right there. Can that fit in? Please tell me you can fit in there. That would be just absolutely perfect. Nice. Then, so that's going to fill up that tank. So the fluid storage in here will get filled up there. That will feed on here. And the thing is, it's actually a low priority for that water. We don't want that water taking high priority. We want it taking low priority. The reason being, the return water from the sour stripper, that return water is going to come down here and end up in this tank. And we want that drawn from first, otherwise it'll back up the system. Just preemptive stuff we're trying to take advantage of before everything goes horrifically wrong. And one other thing we got to check, we have 107 workers. When we unpause this, how many workers will we have left? So, we got 107. Let's unpause the lot. Everything is unpaused. Everything is ready to go. 107 workers will instantly drop to 37. Huh. Okay, so it takes 70 workers to run this little setup. That's not terrible. We're going to need some steam to get this whole thing started, though, so we're going to have to unpause you. That'll drop us down a little bit more, but once this generates a couple of layers of steam, we can turn that off again and let everything run. All right, let's speed her along and see see what mistakes we've made, because I'm pretty sure I've made a few. Oh, and what are you doing? This must be bringing stuff over from over here. You know, we'll let it fill it up. I don't care. We just want to make sure this whole system functions. And this is why we run testing. I forgot to put in the smokestacks, and one of the smokestacks areas was blocked by one of our pipes. So we need to make sure that the crude oil can get through a different route. Shouldn't be too hard. Yeah, grand. Down at a level. So what we're doing here is pushing it to there. Perfect. Then we can break off one from there. Break off one from there. Done. Oh, and maybe do a little bit of a trim on that end pipe. Excellent. We're not even trying to make this too clean, just clean enough that it works. This giant pipe along here, that's not necessary. That's left over from our previous build. Whole system seems to be spinning up. Let's give this another 5 minutes, see if we notice any other problems before we blueprint it. And I also forgot to feed diesel into the rubber production, which is being brought along instead by trucks. Okay, we need to fix that. That was a very quick fix. That pipe just snakes its way around. They've really made the pipe stuff, well, I want to say good, but just very intuitive. You click on something and you click on where you want it to go and the pipes automatically find a route, even if it is kind of weird and clamped on top of things and all that. It works, and it really does look like a factory at the end of the day. This is maybe a little bit loose. We could probably clamp this a little bit tighter together, but I'm thinking for our needs. All right, let's see if there's any more things we missed. Yep, there's more problems ahead. There is light oil. Light oil is about to back up. We're not burning it off fast enough here, making the steam. So the steam over here has full output. Oh, and I should point out, we put in all of these tanks down here just so we can drain off the petroleum. We don't want the petroleum backing up into the system. We want to keep this running so to see what happens long term. So, wow, we have consumed 12% of that reserve. I'm going to have to check our reserve when we go back into our main save because I think I've probably ripped a lot out of the reserve we've got out. Nope, worry about that later. Finish off the design first. So, we want to take this light oil and do stuff with it. However, there's not much you can do with light oil. If we just go under oil, you can go under light oil, and you'll see here, you have two options. One, you combine it with water to make steam, and you make high-pressure steam out of it. That's it. The other is you take light oil and steam to make naphtha and fuel gas. That requires distillation stage 3. Distillation stage 3 is over here, which is beyond research lab level 3, which is beyond the tech we're aiming for. We want to, everything we're looking for, it has to be below tech level 3. We're going to basically research all the tech up to tech level 3, build everything up to there, then use that to slingshot ourselves up to tech level 4, and that will be, and then we'll harness all this tech to make our next design of the oil boilers and, well, the smelters and all that stuff we're going to need. Whew. Anyway, so we need to get rid of this stuff, and the simplest way to do it, it seems, is feed it into a gas boiler. So let's do that and try and keep it. Actually, let's feed it into a power brick. Let's see what we can do with that. What I've figured so far is these high-pressure steam turbines take steam from these things and it spins these mechanical yokies on each end. And then we plug things into the mechanical yokies to make them work. Yeah, I should probably come up with more technical terms than that, but mechanical yokies it is for now. You can... Damn it, I might have put these too close. Oh yeah, no, I definitely put them too close. These things need to go back a step. Well, this is a thing. I have no idea how well this is going to work, but these are the boilers. The overflow oil will get boiled in these, and then it will hopefully turn these high-pressure steam turbines. And these high-pressure steam turbines give off steam low. And the low steam we can feed right back into this cooling tower, which will turn the low steam back into water. In fact, I would prefer if it was depleted steam, but let's see what we can get with low steam. I don't think we have any recipes that can actually take advantage of it just yet. Yeah, steam low. No. I'm not seeing anything. We can use it with seawater to make water and brine, which is... That's actually pretty nice. We need a thermal desalinator, which we don't have access to yet, but in the future, that would be a nice way to dispose of it. That gives us a whole bunch more water. I'm not sure we need it. Alright, let's fast forward this a bit until the light oil starts to overflow and feed into this system. Oh, speak of the devil. Yeah, it's doing its first movement. How you looking? Come on, give us some pressure there or something. I kind of had the inputs and outputs reversed, but we fixed that. Now it's... Okay, they've started pumping. Wow, that's a lot of production. Alright, so that guy is pumping out the power. The power is getting stored in the flywheel. Flywheel is storing the power? Huh. I wonder if there's any way to sort of moderate this. There doesn't seem to be any way, like, to only use the power we need or burn off the oil. Like, you kind of just have to throw stuff at it. I think that would be fine. And you are recycling that low steam. Perfect. Now that low steam should get fed back in here and get a priority output. Right, let's give this a little bit longer and see what happens. We're going to let that continue on and take care of our next bottleneck. Sulfur. Sulfur has backed up in the system, which is going to... Well, the rubber maker is going to be fine, but that does mean the sour stripper is going to start running into problems, and we don't want that. So I'm thinking we get a mixer together and we make fertilizer level 2. We can put that right about there. Set that to fertilizer mark 2, or we could just increase farm consumption. but I think upgrading to fertilizer level 2... Oh, I'm thinking about fertilizer level 2. That might actually just give us more fertilizer, but it burns sulfur. That's all we really care about, is the burning off of the sulfur. So you can go to there, and then you can go to there. Like I said, the way they do the transport belts and the pipes all works out quite nicely. Now you can go up to there. And then what we can do is just delete a segment. That should be that. Perfect. Now that will start filling up the pipes with the new fertilizer level 2. We'll have to see what happens, though. That might take a while to stream on. Though, in all fairness, we would probably be running 4 farms at least, considering the amount of workers that are going to be required to run this thing. Nope. And this over here seems to be working, though. I do not need 4 of these. I think 2 should be sufficient. And maybe 2 cooling towers. We're not getting nearly as much light oil and heavy oil pushing through here as I was expecting. But hey, we'll give it some more time. I believe I've figured out what's going on here with this high-pressure turbine system. It's actually pretty cool. For example, this here is all of our power generation at the moment, and you'll notice it's at 0. The reason it's at 0 power generation is this is actually doing all of it. This is generating 2 megawatts of power, and this is generating 0. Now, you can't seem to control this. Any excess power that's not being used gets dumped into the battery. And the battery is the flywheel. So the flywheel is basically just a big metal thing that spins and stores the energy for later. A little bit inefficient, but it works. Now, as you see, as we run out of energy and this thing spins down because we don't have any more steam coming in, the diesel generator over here is kicking in and burning off diesel to generate electricity, which means it auto-balances. We will not use the diesel to power this generator unless this thing runs out of steam. So... well, yeah, this thing will, of course, run out of steam frequently because it's only going to be intermittently topping up from these 2. Though now that we've got both of those running, we'll have to see. One other downside. Yeah, this sulfur, we need some other way of burning it off. This is a problem. You see, even though we're trying to make fertilizer level 2, this thing keeps backing up. We're not burning off the fertilizer fast enough, which means the sulfur keeps backing up in the system, which means the sour stripper keeps backing up. And because the sour stripper keeps backing up, that means the sour water over here is going to back up, which will clog up the whole system. So we need some way of getting rid of either the sour water or the sulfur, which leaves us a problem. Sulfur, the only thing I can see to really do with it is either burn it off for 48 air pollution, turn it into acid, which we can use to help with our copper production, though I don't think there would be enough copper production to... You know what, let's have a quick look at the copper production because it's kind of interesting. This is the copper electrolyzer. Normally what you do is you put in impure copper and water, you get 19.5 copper sheets out. If you put in acid and impure copper, you get 24 copper sheets out. So it's an increase of about 20%. You get 20% more copper for what you put in. But it does take acid, and to make acid you need to grab, where is it? Ah yes, you grab a mixer, put in 6 sulfur, 30 water, you get 36 acid. It only takes 6 acid to run this, so this is actually a pretty handy way of increasing copper without too much effort. Well, okay, it's going to cost you 4 workers and 100 kilowatts, so it's not exactly free, but it does mean we could boost copper production for very little effort. But it's not going to burn much sulfur. That's sort of the problem. Sulfur is just going to, laugh at that. So, that still leaves us with other options, which is combine the sulfur with limestone to give us slag, which we could then dump. It's a good way to get rid of a large quantity of sulfur. Other options are to actually just dump the sour water itself, let the sour water overflow, take that sour water, and just dump it into the ocean, which gives a whole bunch of water pollution, which is quite nasty. I don't think so. I think we could stockpile just enormous amounts of sulfur. I take it back. I think we're going to go with slag. Slag will allow us to do some landfill. That landfill we can use to reclaim some of the ocean back. And it does eat a lot of sulfur. It eats 30 sulfur every 60 seconds, and this thing only produces 12. So it's a great way to dispose of excess sulfur. So I think we'll probably leave in the mixer as well, so we can get fertilizer level 2. I mean, for making slag, we're going to need limestone. So if we've already got limestone coming in, we might as well make the fertilizer level 2 straight up. Fertilizer level 2, I have discovered, can go up to 40%. Let's have a quick look here. Fertilizer overviews. Basic fertilizer, maximum fertilization 120%, so a 20% bonus on top of max fertilization, and max fertilizer level 2 goes up to 140%. So we can really stretch the productivity of the farms. I think we can use those to sell to villagers if I'm not mistaken. We can trade with, say, this crowd here, and is there any way we can give them food? What, you don't want food? You people are the worst. There's got to be something we can do with that food. I'll worry about that later. Oh, this is This is a beautiful design. The developers... Alright, so when it came to this mixer, I was trying to put down two of them. I wanted one mixer to do the fertilizer and one mixer to do the slag. However, I'm being an idiot. Turns out they already anticipated such a thing. So all I've done is I've prioritized the fertilizer recipe, put it on top. That way, if we have fertilizer, we have limestone, and we have sulfur, then we produce the fertilizer. And the fertilizer goes out here, fertilizes the farms. Farms are all super happy. In fact, let's check their targets up to 140%. There you go. Lovely. Tasting down that lovely juicy fertilizer. Now here's the thing. What happens when this fertilizer backs up? What happens then? Well, if the fertilizer backs up, that means we're going to end up with more than 6 sulfur. In fact, we're eventually going to pop up at 30 sulfur, and when that happens, the slag recipe will activate. So that means this will keep producing fertilizer until it backs up on the line, and then once it's backed up on the line, it'll automatically start making slag for us. That is just perfect. In fact, ooh, we need to figure out some way of getting water in here as well. Is there a way to input water? Or is it only fertilizer? Oh, damn it. If we could do all three, that would be hilarious. No, we can only do... Oh, yeah. So if we take off fertilizer here... Yep. Damn it. I was really hoping to be 2 water inputs. Otherwise, what we could do is we could have the acid, have it do acid as well. But I like that. That is just... that is good game design right there. I think that's enough for today. We've managed to make ourselves a nice little system that'll get us the fuel we need and should get us all the way to tier 3. And as well as that, it seems to be almost self-powered. As in, this diesel generator doesn't really kick in anymore. Well, it takes a while. This thing needs to have a backup of both heavy oil and light oil. We could, of course, just get rid of those storage tanks to make the system a little bit leaner, but yeah, I'm still worried there's going to be more problems. We encounter, say, a few 100 cycles down, or whatever the hell the thing is in this. Oh, and we can probably siphon off some of the sulfur to make acid for our copper refinement, though I'm in no rush to do that. Turning it into slag is just a good way to dispose of it. And I think this system is definitely large enough. It's, yep, it covers it. So let's make a blueprint of this, and then we can take that blueprint to this. Actually, wait, no. First thing we need to do is we need to kill this line. We just want to make sure that we don't have anything included that we don't need. So you can get cut off. That's why all the tanks here, every single one of them are level 1s. We want to make sure everything is as cheap as we possibly can. And one last thing, where is it? This thing, the sour stripper, that costs construction materials that we don't have access to just yet. We will shortly, but it does mean that this thing's not possible to be produced until we've done a couple of things. But this, yeah, this is sort of the joy of the game, finding out how everything fits together and all the ways around all the problems. And there we have medium oil, which should hopefully get us through to where we want to go. This I'm kind of curious about. You see, these things can take fuel gas, and later on there's ways to turn medium oil and light oil, or heavy oil and light oil into fuel gas as far as I'm aware. There's where to split them down, and you could generate just enormous amounts of power from what I'm seeing, though. Considering that this is a finite resource on your island, and we would have to, well, if I had to bother to read the information, shows the overall status of the ground reserves of crude oil in this deposit. This is a limited resource. We need to find a new one before we deplete it. Long-term sources of crude oil need to be found in the world map, which means those oil rigs we found out there, we're definitely going to need to cut into them. This is the oil system we're trying to replace. As you can see, it looks much more tiny. Yeah, I think tiny is the word. Oh, that is a painfully small oil system. However, I've been faffing about too long because we have already drained 32% of this oil reserve. That is, that's not great. That does not seem like a good thing. While I was learning the ropes, I've been draining the oil quickly. We're going to need to chuck in that oil supply real quick. And we need to start using this thing. This thing here is this cargo depot can go out and grab us oil. We're going to send this thing out to grab oil. It'll come back with 440. We plug that into the system, unload it. But it still takes a whole bunch of fuel to make this thing work. It requires 90 fuel for a single journey. So we're going to be burning 90 oil to get our hands on 50 or 440 crude oil. Yeah, we're going to need to expand this out. This thing can get bigger and carry more per trip. So we're going to need to prioritize that because this stuff is going to run out really quick. Well, relatively quickly. And the other batch of it's way over here. And it looks like an even smaller batch than the current one we've got running. Oh my god, it is actually smaller. That's like emergency oil. Ooh. Anyway, We've already seen the design phase. I will build the oil thing right about here. I'm going to cut all of that footage out, though there's no point showing you me building it in the actual game. You've seen the design of why we're doing what we're doing. I'll give this at least one more episode, and after the oil goes in, I'm thinking we definitely got to do steel and a few more, and probably, you know what, there's going to be more. There's going to be so much more we have to do anyway. I'll figure out what it is when the time comes. Anyway, I'm going to cut this out here. I hope you enjoyed, and good luck.